So if we look at from the periodic table, we could come back and just say that we know for atoms 1 through 82, right? This is hydrogen to lead are stable. In other words, not radioactive. And what we're going to find here is that when I look at the strong force is much, much bigger than the electrical force. And that's what really makes them stable. Then what you're going to see here is that if I start looking at atoms where we go from 83 to 92, this will be from bismuth to uranium, are unstable. They're unstable, and so they're unstable with no stable and what we're going to find here is that in this case, the strong force is approximately the same strength as the electrical forces. And then when we go to the next set of atoms, where we go from 93 to 108, what we find here is that these atoms, they're also are unstable, but do not occur naturally. So what you're going to find here is that they can be manufactured, but if you try to put them in nature, you'll find that these strong forces are typically less than the electrical forces. So you have to build them very, very, very carefully. So in order to really see what do I mean by this, what we'll do here is that we want to talk about stable atoms or stable nuclei. Stable and unstable. God, I keep spelling that funky. And unstable nuclei and the band of stability. And what we'll do here is that what I'm going to start off by looking at this is that I'm just going to give you, I want to give you some observations about the band of stability. And what this tells us here is it's going to tell us what are stable isotopes, what are non-stable isotopes, and what atoms don't exist at all. And you're going to see that you're going to see various pictures of the band of stability. I'm only going to use this one right here just because the numbers are nice and clear. But then when we start looking at radioactivity, I'm going to change it to a different band of stability, and then I'm going to bring in the valley of stability. So let me go grab that image so you could see what I'm talking about. So this is the image I'm after right here. This is the band of stability. When you look at here, let me just show you what do I mean by, a lot of the times they call this the line of stability too. And I think what we want to really pay attention to here is that as far as we're concerned, we don't really want too many things here. So this doesn't give us enough detail. But note that the black is actually a band, but I'm going to just show you this briefly, then I'm going to delete it because we're going to use it later. And sometimes you'll see that these two curves are exactly the same, but look at the black line. They call this the line of stability. But it's not a line, it's a band. But you'll see that we'll use this when we start to look at radioactivity. So I'm going to delete this right now. This one's nicer just for what we're doing right now. Okay, so here we go. So what you're seeing here is that if I want to make some observations about stable and unstable nuclei, what I would say here is that I would say that the first thing that I would say is that there are 3 regions. One of these regions is the black dotted band. That black, dotted band. So when you look at that, this is where all stable nuclei are found. So we can go look at some of these atoms here. So one atom that we could look at is that we can look at copper. So if I look at copper, for example, well, actually, let's not do that just yet. I think I'm jumping the gun here. And there's this other band here, is that then you could see the yellow band. These yellow band are unstable nuclei. And then what you see here is that there's actually a third. This is the blue, the light blue region. No nuclei exists. So if you find an atom or a nuclei that's in the blue region, well, it doesn't exist. So let me give you an example. Let's start off with copper. Okay. So if I look at copper, this is what copper looks like right here. So what you're seeing here in this band here is that, note that the vertical axis is the number of neutrons. The horizontal axis is the number of protons. So what I'm saying here is that the vertical axis is equal to the number of protons, where the horizontal axis is equal to the number of protons. And what you're seeing here is that you're seeing a couple of things here. So now let's go look at copper. So let's go calculate the details of copper. So if you look at copper, and I find that it's 64, 29, and here's copper. And if I calculate this thing, then I know that I have 35 neutrons and I have 29 protons. So let's go look at this thing. So I'm going to go look for 29 protons. And I'm going to draw a red line. So look at the 29. So the 29 goes about, the 29 line goes, let's say, goes about right here. So I'm just going to draw a vertical line where I think it's going to be close to 29. So it's not on 30. So I'm going to say that that line represents 29 protons. Now let's go look at 35. So if I look at 35, it's got to be right smack in the middle between 30 and 40. So assuming that my line is straight right here, check this out. This guy, oops, that's not 35. It's more like down here. So this guy is 35 neutrons. So what you're seeing here is that because this lies on the black band, it's a stable isotope of copper. But let's say something different here. Okay, let's say something different. Let's say that, suppose someone claims that there are two other stable isotopes of copper. And what they claim here is they say, oh yeah, 74 copper and 84 copper, that those are really stable isotopes. Well, then we should go calculate their numbers here. So if we go calculate their numbers, this one says that this reads that this is going to have 45 neutrons. This one's going to have 55 neutrons. And because they're all copper, there have to be 29 protons. Let's do this in a different color. And then this is going to be 55 neutrons. And of course, this is 29 protons. So if I go and I look at this thing, where does 45 land? So I need 45. So the 29 is the same line. But if I look at 45, here's what I see here. So this color is green. So now I'm going to go try to draw 45 here. And if I draw 45, here's 45 neutrons. Look where it lands. It lands in the yellow region right here, whereas this one lands in the black band. The fact that this lies, so this tells us here is that this lies in the yellow band. So the yellow band says that it's unstable. It's not a stable isotope of copper. It's an unstable, so it's radioactive. And then if I go to 55 neutrons, if I go over to here, and we claim that this is 55 neutrons, note that this guy lands in the light blue here. So this lies in the light blue region. So what this tells us here is it does not exist. So by looking at the band of stability, we could then talk about which nuclei are stable, which nuclei are not stable, or whether something exists or not.